So this is section 4 from the textbook. Now, this is related to the difference of squares rule, which we learned already. So if you recall, difference of squares was a squared minus b squared. And when you factorize that, you'll get a minus b, a plus b, like that. Excuse me. So when you expand that, you should get a squared minus b squared. There's two ways you can look at that, like using a diagram. Expanding, you'll get the answer, but we can use a diagram. So for example, if we have this square and we can see the length is a and this length is a as well. I didn't put that on there. So this whole thing is a squared. So that whole shape there is a squared, the area. So a times a squared for the area. Like that. And then we have a small square here, which is b times b. So that area there is b squared. Like that. So when we cut that out, so when we remove this small square, this area here will be a squared minus b squared. So that blue area will be a squared minus b squared for the area. That's in blue. Okay. And what they just did here, they just cut down the center and they rearranged. So they put this bit here, let's call that part 1, and this is part 2. So they put part 1 here and they put part 2 there. And they just rearranged it to be this shape here. And you see we have a rectangle. And the length here, this was a from this side. And then this length here is b here. So this length is a plus b. And this length here is a minus b there. So we can see that a squared minus b squared is a plus b times a minus b. But you can read that yourself. And this is the way that I showed you, I think, last week or the week before, where we have a diagram where we've got a. This length here is a. And so they cut this piece off and they put it down here. So they just rearranged it. So this area is a squared. This area is b squared. And then when you take away this small square, we have this piece left. So we just join it down here. And so you'll end up with a plus b there. And this length is a minus b, that's here. So basically this big one is the blue one, which is this one here. And that red one, let's make that green. So that's put here. So they're just rearranging the two shapes. So that would conclude then that a squared minus b squared is the same as a minus b times a plus b. So if you're not very good with algebra, then you can use the diagram to help understand about this. But you basically get the answer by expanding anyway. And we used this last week when, for example, we had something like, let's do an example, 4x squared minus 9. And we can see we've got a subtraction here, a subtraction sign, and we can make these both squares. So if you can make this something squared minus something squared, then we can write the factors here. So 4x squared would be 2x all squared, 4x squared, minus 9, which is 3 squared. So based on our formula, where we've got a squared minus b squared, that is a minus b, a plus b. So that's the same as a couple of weeks ago. So then you would have 2x minus 3, 2x plus 3. And we will use these methods when we do quadratics. We need that to help factorize some quadratics. And another example is if you could have something like, okay, we could have 4x squared again, but then this may be 8. So we can still do that, but we have to make our 4x squared 2x all squared, as in this example here. But 8 is not a perfect square. So we would make that root 8 squared, because root 8 times root 8 is 8. You can check your calculator about that. If you're using powers, root 8 is actually 8 to the half power. And I'm not sure if you've covered fractional powers. I don't think you have. So I want to cover fractional powers later if we have time. 8 to the half. And then we know half plus half is 1. So that's another way to look at it using the fraction power. So if you go to your calculator and you go 9 to the half, you'll get 3. Because 9 to the half is square root 9. So you can look at that yourself a bit later. So we're going to use this idea here. Well, also, we could go 2x minus root 8, 2x plus root 8. That can be simplified more, but we'll do that later, another time. So we're going to use this idea and factorize questions that have power 4 or 6 or 8 or something like that, higher powers. So you've got x4, y4, and 64. So x4, you think about x4, y4, couldn't we write that as x squared, y squared, power 2? 2 2s are 4, 2 2s are 4. So we can change that one, and 64 could be written as 8 squared. And we have a minus sign, which we need. If that's plus, we can't use this rule. So we'll write that again. X squared, y squared, power 2, minus 8 squared. Like that. So we can use our rule, a squared minus b squared. Let's write that underneath. A squared minus b squared, which we know is a minus b, a plus b, and then we just put these numbers in on the top. So that would be equal to x squared y squared minus 8, x squared y squared plus 8. And that would be your answer there. So if it helps you, you can write the formula below to help you put the numbers in. So that's your answer here. So those are your factors, right? So that's example 1. It's in your textbook. You can see these ones are from the book. So you don't have to copy if you have your textbook there. So this one, okay, we got 25b4, 81c squared. So can we make these something squared minus something squared. That's what you're trying to do first. So 25, we know is 5 squared. So we've got 5. B4. So we'll split B4 to B squared and make that all squared. So 5 squared, 25. B squared squared is B4. Multiply here. Minus 81, which we know is 9 squared. C all squared. So get good practice at changing these to have power 2. So we have the right form now. So A squared minus B squared. Write our formula. A squared minus B squared is A minus B, A plus B. You can put A plus B first, doesn't matter. So then we have 5B squared minus 9C. Five B squared plus 9C, like that. So that would be your answer there. Those are your factors. So not really that hard. The only trick is changing it to this form here. What about, oh, one might let you work a little bit. I'll start you on the first one. This is exercise 4. 1, 2, how many questions? 10. Okay, it won't take you too long, and I'll review some of them, and then I'll write the answers to the other ones, and then we can look at exercise 5. So maybe work on that until about 8:30. Okay, so that's about 16 minutes. But the first one, I'll start you off. So we're looking to do this every time. So each question, write this on your page like that. And we always have a minus sign here. So 144 is 12 squared. A is already squared, so you would put A here, and x4 must be x squared. And then your factors would be 12 minus A x squared, 12 plus A x squared. I'm going to give you 15 minutes to do this, all right? Those 10 questions. And then you can read the next section a bit if you're fast. All right, do that for 15 minutes until 8:30. So I'll do a few solutions. Some of you are still working probably, so just keep going and you can come back and check your work here. So for this question, we've got A squared, B squared, C4. So this is going to have to be A, B, C squared. 64 is 8 squared like that. So we'll have A, B, C squared minus 8 for your factor, and A, B, C squared plus 8 for the other factor. So those are your two answers for 1 and 2. So just check you got that answer okay. And question 3, x6, y6. So we want that as power 2. So x6, y6. So this would be x3, y3, power 2, 2 on the outside, minus 4 squared. Like that. So x3, y3 minus 4. And x3, y3 plus 4. So those are your factors there. All right, question 1. Well, 1 is 1 squared, so that's easy to do. So 1 squared minus p squared. So it's already square. So p q squared squared, like that. So then we can write the factors. 1 minus pq squared, 1 plus pq squared. There you go. So it's pretty straightforward, isn't it? Not too hard, like that. That's question 4. So just check that quickly. We'll go down to 5. 81. So 81 will be 9 squared. 65. 625 is 25 squared. P4 squared. So 25 squared is 625. P4, 4 2s are 8, P8. So we can write our factors. 9 minus 25 P4. 9 plus 25 P4. There you go. So any question, just ask. Make it green. It's that one there. So this one's the same. Even though it's got a bracket here, we still do it the same way. So this is your A. So A squared minus B squared. So that B needs to be changed. So we'll have x plus 1. So don't expand it. Minus S3 squared. 2 3s are 6. So we have our form, A squared minus B squared. So that's going to be A minus B, A plus B. So x plus 1 minus s cubed, x plus 1 plus s cubed. Finished. Like that. Question 6. Question 7. So now you've got this problem where it's not a perfect square. So the 3 is going to have to become root 3. X5 squared. Root 3 times root 3 is 3. So you could remember the rule, root A times root B is the same as root AB. Like that. So remember that rule, that's quite useful. And 11, again, it's not a perfect square, so we're going to have to make that root 11 squared. Root 11 times root 11 is 11. So now we have our form. We just happen to have these things called surds. So root 2, root 3, root 5, these are called surds. We can't simplify them. That's how we leave them. So your factors would be then root 3 x5 minus root 11 then root 3 x5 plus root 11, like that. Now in question 8, we'll highlight that. In question 8, you should take a common factor first. Take out 4. So as I mentioned the other day, always look for common factors first. So here a common factor could be 4. So we'll end up with 4a4x squared minus 9. So the 4 can be ignored now. We just leave that alone. And then your 4a4x squared could be changed to 2a squared x all squared, because now we need to make this power 2. And 9 would be 3 squared. Like that. So now we can write the factors for this part. So we'll end up with 2a squared x minus 3, 2a squared x plus 3. All right, and keep your 4 there. That's part of the answer as well. So you can double check by expanding. You should get that as the answer for question 8. So you can copy that down if you're not sure. I'll leave it there a minute. So question 9, no common factors, and 10 as well, no common factors. So 9 could be written as 3a squared minus 25, which is 5b squared. 2 2s are 4, 5 squared 25. Okay, so this is okay. And then we write our factors. 3a squared minus 5b squared. 3a squared plus 5b squared. So that's your answer there. And the last one, nearly finished. 10m4n6. Well, 100m4n6. So 100 is 10 squared. M squared, all squared, minus n cubed squared, 2 3s are 6. Remember, we always try to get the power 2 on the outside. Like that, everyone. Okay, so once you've done that, you can write your factors. So 10m squared minus n cubed. 10m squared plus n cubed. That's finished. All right, so that's that exercise done. So hopefully you got those okay. I'll post a video later. So if you do miss something, you can copy it later. But download the video from the line group because they do expire after 1 week. I will try to put them all in the Google Drive as well and share the drive later. Okay, so in this exercise down here, they get a little bit more complicated where you might have to use more than one rule. So if you look at this problem here, we recognize this from yesterday. So we've got this bit and we've got this bit here. So I'm thinking we can do something with this here. So you've got x6. What we don't do today, we'll do early next week. So x6, we'll do this bit, plus 2x cubed plus 1. This looks a bit like your perfect square rule. So we're going to have x cubed squared plus 2ab plus b squared. So this is actually the rule from yesterday. Do you recognize that? Maybe not, but that's why it takes practice. So you've got a squared plus 2ab plus b squared. And we check these are the same, 2ab. We check this 2ab part and looks okay. 2x cubed, 1 squared, and 2 3s are 6. So we're using that rule from yesterday, which was a plus b all squared. So that would be x cubed plus 1 all squared. So this bit can be written like that. Okay, so I just did the green bit first. So the x4, we'll do that bit now. So what we can do now is just write that as x cubed plus 1 squared for the green part, because they're equal. And then I've got minus x4 here. So we can make the x4 x squared squared. So we'll do that. X cubed plus 1 squared minus x4, which is x squared squared. So now you see we have difference of squares. So now we have a squared minus b squared, which is a minus b, a plus b. So then we just write our factors. So we'll have x cubed plus 1 minus x squared, x cubed plus 1 plus x squared. So that would be your answer there. Quite a long one, because each factor has 3 terms. Okay, so that would be the answer there. So you see we use 2 rules. We use the perfect square here, perfect square rule here, and then we use the difference of squares here. Difference of squares there. So there's 2 rules to these questions. That's example 1. Example 2 is quite long. Let me take a look. Right, for this one, you've got 2 bits. You've got this bit here. So you've got A, B, B. So you may recognize that from yesterday. And we've got C, C, D, D. So we actually have 2 things that are similar to yesterday. So we could write that out as A6 plus 4A3 B2 plus 4B4. Now I'm going to put a minus here, but I'm going to make a bracket. That means that these 2 signs will change to positive. C4 plus 8C squared D squared plus 16D4. So these are equal now. Just be aware that I made a bracket, which means that these signs here have to become positive. So, and because you minus everything. So minus C4, minus 8, minus 16 when you expand the bracket. And I could put a bracket around there, but I won't do that for the first one. So if you look at that, you may recognize this from yesterday again. We've got A cubed squared. So we think of perfect square. And then we've got 2A cubed. And this will be 2B squared plus 2B squared squared. So this green bit, I'll keep it in green, can be written like this from yesterday. That's the perfect square. And we can check it. 2A cubed, 2 2s are 4. Okay, here, A cubed, B squared. Okay, so this is from yesterday. And then we can do the same for this one here. So we've got C squared plus 2C squared. And the last term is 16D4. So that would be 4D squared plus 4D squared. Okay, just from yesterday, perfect square. And the middle term, 2 4s are 8. Let's just highlight that there, because that's the same. So just check this, 2 4s are 8, c squared d squared. So it looks like we did it right. So now those can be written as perfect squares here. So we can write that as a cubed plus 2b squared. I know some of you probably don't get this very well yet, but go back and look at the video and copy the question now. And then this is c squared plus 4d squared. And that's squared as well. Okay, looks okay. So now you can see, now we have difference of squares. And I think these questions, we will start today, but we'll finish them next week. And so you've got these two bits here. This is your A and B. So this is A squared minus B squared. So you're going to end up with your final answer as the first one minus the last one. You need to be careful now with this part because there's two terms. So you've got A cubed plus 2b squared minus this. So you should put this one in brackets, c squared plus 4d squared, like that, and then we add them. So a cubed plus 2b squared plus c squared plus 4d squared. This one's okay, but this one we can tidy up because of this bracket here. So this one would need to be expanding the brackets. So a cubed plus 2b squared minus c squared minus 4d squared. I know it's quite terrible, isn't it? Very long. A cubed plus 2b squared plus c squared plus 4d squared. And none of those can be added. They're all different, A, B, C, D. So you're going to end up that with as your answer. So I'll put that in green. Quite long, isn't it? So, but you won't see too much of this in grade 10. Some things you do see, the basic idea, but not too much of this kind of factorizing. So you should be happy about that. Okay, if you haven't got it, you can watch the video again. There's only 7 minutes left, so why don't you try this one here? Notice you've got this and you've got this. So I'll start you off a little bit and then you can try a couple and we'll do more next week. We'll finish them off next week. And then we've got, okay, so A4 minus 2a squared b plus b squared. It's looking like it could be perfect square because you've got A, B, and B, and 3 terms. So we could make that a squared minus, now from the rule, we would have 2a squared b plus b squared, which can be written as, let's just check it's all right. Yeah. So this is perfect square. As in one of the examples back there. So that can be written as a squared minus b all squared. So this is for this part here. And then we've got 100, which is 10 squared. Like that. So we've got our square from this part, and we have 100, which is 10 squared. So then you can write that as a perfect square. A squared minus b all squared minus 10 squared. So now I've just gone down to here. So now you have your difference of squares. So that's a squared minus b minus 10. A squared minus b plus 10. So you should get that as your answer there. Okay, and when you come to question 2, I'll leave that there a minute. But for question 2, you're going to need to put your minus c squared away over here, because you've got x, y, x, y. C is different. So move c out the way. So you have x4. What I would write would be x4. I'll put the combined term in the middle like yesterday, minus 6x squared y plus 9y squared minus c squared. So these are your two parts that you need to deal with. This one's okay, that's c squared, that's finished. But this bit, you need to do your complete square here. This is also a perfect square, like this one here. So we only have 5 minutes, so you try and finish that one yourself. And I'll talk about it in a minute. And then the rest we can do next week. Okay, so for this question, x4, we can make that x squared squared. By your perfect square rule, we would have 2x squared. This is 9y squared, so that's 3y plus 3y squared. So I'm just writing this down from yesterday's lesson for perfect square. Check it, a squared minus 2ab plus b squared. And you can write that as x squared minus 3y all squared. That's perfect square there. So that yellow part can be written like this. And then the simple bit is the c squared on the end. So you'll have x squared minus 3y all squared minus c squared. So now you have your difference of squares. Here. So then we'll just write the factors. X squared minus 3y minus c. X squared minus 3y plus c. And those will be your factors here. So you should have got that. So next Monday, we will do a bit more on finishing these. So I'll stop at this one here. And I'll stop here with the other class as well at question 2. And after that, we have a few more questions to do on Monday.